to our fifth episode of Anatomy Week, and today we're doing Microglia. So what is microglia?
Well, there are next type of glial cell. So microglia are found in the central nervous system, and they're basically like the cleanup crew, like the janitor. They're gonna clean up all the debris, and they're gonna be the immune system of the central nervous system.
That's amazing. Now
Yay!
let's look more in depth about what they do.
Yes. Okay, so microglia. If we just take a little look at the word, like micro, what do
hmm
you think when you see micro, Kate?
Like small, like microorganisms. They're smaller, right?
Yes. And then glia, we kind of talked about a little before, that means glue.
Mhm.
And that's just like the category of cells. So microglia are like small immune cells in the central nervous system. And on the right, we have some of their functions if you want to read them out.
They phagocytize debris. So does it mean like they surround debris and just like
They
it's
like
kind of
eat
like
it
a
up.
lysosome,
Yes,
right?
So basically, like they have lysosomes in them. So they're gonna eat up all the debris and then they're gonna put that in the lysosome and break it down.
That is so cool. And
And then
pathogens.
yeah, so they're gonna like take those pathogens
Uh-huh.
like and phagocytose them with the debris and all like the dead cells and stuff.
How about prune synapses?
So basically, like when you're developing, you a bunch of synapses form, and then you have to like cut them down so that you don't have like too much going on in your brain, and so that those connections that you form are robust. Microglia help to do that.
Mm-hmm. Inflammation.
So when you get sick, they're gonna regulate inflammation, which might sound bad, but like they're gonna bring all those good chemicals and all their other immune cells to make sure they can kill that infection.
Wow. How about glial interactions?
Um, that is like they help. Astrocytes help a lot with the inflammation process and illness and scar formation, so that's
hmm
usually what that means.
Wow.
Okay, so talking a little bit about where they're derived from. The cool thing about microglia is that they're not from they're not derived like the other glia. So they come from the yolk sac.
hmm
They're not gonna follow the normal immune cell lineage with like monocytes to macrophages. They follow their own little thing. So they migrate from the yolk sac. They start as macrophages, come into the embryo and into the brain before the blood-brain barrier develops. And then once they're in the brain, they're going to develop into microglia and they spread throughout the brain and the spinal cord. Once they're like, once you're an adult, your microglia kind of self-renew. They're quite long-lived, but
hmm
they do have to proliferate locally.
Mm. And they're all over the brain, right? It's like,
Uh-huh.
mm,
So do you remember like where normal glia come from? Like astrocytes and all the other ones?
mm, not really.
So they come from the neural ectoderm, which is like
Oh.
kind of how the central nervous system develops as
hmm
well. So that's like something I see tested a lot is like microglia are the only ones that are special in terms
Mm.
of where they're derived from. Now we can go into a little bit of these functions. So this poor cat, it's so sick. Think of this. This is like a sketchy neuron. Like
hmm
maybe the neuron has a toxin in it. That's not good. We
hmm
don't want that toxin getting to other neurons. So what's
Yep.
gonna happen next?
Microglia comes in.
Yes, and it's like, wow, that cat, that looks really sus. That's sick. We don't
Mhm.
want that there. So what's it gonna do to it, Kate?
Kill it because like cytosis.
Yes, So the cat is gonna get hit. So microglia, they're never really resting. They're always like surveilling their environment. So they have little processes like we saw before. They're gonna extend those and retract them to kind of like suss the other ones out, monitor synapses, make sure, hey, there's no like weird activity going on here. They also monitor other glia and neurons, checking for cell damage, pathogens, or abnormal activity.
Wow.
So, what's this cat doing?
It's eating.
Yes, so it's gonna like eat up all these cool things that you see on the right. So we have pathogens, we have dead cells, we have myelin and other proteins. Basically, they're gonna remove a bunch of apoptotic cells during development because when your nervous system's developing, you have to kill off some cells to form better
Mhm.
connections. They're gonna clear those dead neurons and clear any glia after injury. They're gonna phagocytize, as we said, cell debris, myelin fragments, protein. Um, and this is important because
It prevents inflammation, and allows for tissue repair and ultimately maintains a healthy extracellular environment.
yes. And so without microglia, like your debris is going to accumulate, your recovery is going to fail. So this is why in things like Alzheimer's, you see those protein aggregates and stuff. That's not good. That
Oh.
means your microglia are not cooking and your cells die.
Yep. the alpha beta
Yes.
plaques.
Uh-huh, uh-huh. Yes. You don't want those. Those are not good. And your tau tangles,
Oh no.
Oh wait, no, neurofibrillary tangles and tau
And
plaques.
yeah.
Bad. Okay, so
Ooh.
here we have an image of how a microglia can strengthen it. So we saw
Hmm.
there was that little pink thing that
Yeah.
binds to the purple receptor.
Hmm.
The pink thing, growth factor, and it's going to bind to its receptor on another cell.
Hmm.
And that is going to strengthen the synapse. But the thing that actually strengthens it is the microglia, because they're going to be like, don't cut this synapse. This is a good synapse. We want to make it stronger. So that's how growth factors and microglia interact.
Wow.
And next, we have an example of a synapse that isn't going so well.
Hmm.
So these neurons do not want to hang out. They do not like each other. They're ew, gross. No connection formed, right?
Hmm.
So, they're gonna start releasing these things called complement proteins and cytokines.
Hmm.
Basically, it targets them, and the microglia comes in and is like, wow, that's really sus. They have all these proteins displayed. They're like, ooh, like we don't like each other. Kill us. We don't want to be next to each other.
Hmm.
So the microglia is going to weaken that synapse and make sure that no connections form between the two.
Uh-huh.
And the microglia will consume the synapse and phagocytize if the
Wow.
neurons like that specific area doesn't need to be there.
Mm.
By synapse. Okay, so do you want to do a little review of all the fun things that microglia do?
Yep. So first, they monitor the cell activity, like because just was talking about the protein, right?
Yes, the complement proteins and the
Uh-huh.
cytokines.
And then immune surveillance. So if there's like pathogens or something suspicious, phagocytosis, phagocytosis, set aside. And then they clear the debris. It's like what we were talking about at the beginning of the video,
Mm.
like the janitors, right?
Yes, uh-huh.
Like they clean up the cell and make sure the cell is healthy and can continue to survive.
Yes.
And then remodeling synapses. Did we talk about this?
We did, like in development and stuff, like if the synapses don't need to be formed, it'll cut that synapse, like the sussy cast,
Hmm.
it'll remove them. But if the growth factors are secreted, it will help strengthen them so that that synapse stays.
Yay! And lastly, ordering inflammation.
So we didn't talk about that one as much,
Hmm.
but basically like those cytokines that we talked about, those will be present in if there's an infection.
Hmm.
And so the microglia will kill that cell and eat it up, phagocytize it so that it doesn't spread to the rest of the central nervous system.
Wow, that's amazing.
And then finally we have our little ref sheet bit if you want to use that for your own ref sheet.
Hmm.
Well, thank you so much for listening.
Yeah, thank you so much for watching our episode, and we hope to see you next time on our sixth episode.